Hello everyone. Today I will introduce a very new concept. So you can see in the figure, this is figure A and this is figure B. So this shows some kind of crystals which forms during solidification. So during solidification we have initially the liquid which is going to get transformed into solid, and this solid will have some crystals. Okay. So when the solid it forms, we know it is the nuclei which first forms, right? It is the nucleus. It has some critical size, that is R star, that is equal to minus 2 gamma s by delta Gv. That you know about this solidification. So what is the difference between figure A and figure B is that the one is showing faceted growth and other is showing non-faceted growth. Okay, so what is this faceted growth and non-faceted growth? So we'll see here. So first you try to identify which is faceted and which is non-faceted. Okay, now I think you all have thought, so I am just telling you that figure A is your faceted growth and figure B is non-faceted. Okay, so this is the thing, like first one it is the faceted one and second is the non-faceted. Non-faceted one, that means when we see growth happens in every direction, it can happen in any direction, right? So as it happens in the case of like dendrites which form. Okay, so what happens? So it forms in certain all directions, and this faceted tries to grow in a particular plane and it forms a face kind of thing. Like we have certain face here, like you can see this is the face, this is the face. Okay, so this is your faceted one and second is your non-faceted. Okay, fine. Okay, so now, so how an element decides that I need to grow using this faceted or non-faceted one? Okay, so that depends on the values which are given over here, and these are examples. So one is your gallium and another is your indium. Okay, here whatever the diagram it is given, so these are for this. Okay, we know the melting point we have, right? Then enthalpy of fusion we have got. Okay, so these two values will be given. Okay, and there is a parameter which is used to decide whether this will grow faceted or not, that is called as some constant term, that is alpha, that is equal to L by RTM, where L is equal to latent heat of fusion or enthalpy of fusion, you can say. R is gas constant and Tm is melting point. Okay, this is the constant which is used to determine. So what is the condition? The condition is that if alpha value is greater than 2, then we get faceted growth. If alpha value is less than 2, we get non-faceted. Okay, so what is the physical significance of this alpha? See here that this alpha can be written as like L by Tm divided by R. So L by Tm, that is delta H by Tm, also gives entropy. So this is the entropy of formation of this solid. Okay, so delta S by R. So basically this alpha tells you about the term called entropy. Okay, so here when this alpha value is high, that means it gives a meaning of entropy, that means more randomness. When we have more randomness, that means that is more stable, you can say. Okay, so this is what, when we have this faceted growth, then it is assumed as more stable. Okay, so this alpha value which is there, so this is tells you about the entropy, but this is, you can say, numerical entropy. It's dimensionless entropy, you can see dimensionless entropy. Okay, so let us see for this, and I want to tell you that this is for gallium and the second one it is for indium. Okay, why? You can, I have matched here, but you can see from this formula equal to alpha is equal to L by RTM. So let us decide first for gallium. So alpha is equal to R by Tm. So L is how much? 5.59 into 10 to the power 3 joule per mole. Then R 8.314 joule per mole per Kelvin, right? Then this Tm, that is melting point, it is 29.8. It is in degree centigrade. So we need to convert it into Kelvin. 29.8 plus 273. So guys, try to calculate. I am also calculating. $5.59 2000 divided by 8.314 into 29.8 plus 273. So I am getting 2.22. So so here it is, for value of 2.22 we can say it is faceted, and we can easily say that this one is faceted. That means gallium will be this one, because this is showing your faceted group, right? So that means the gallium shows the faceted group. If it next it is indium. Next alpha, we'll find it as by 8.314 into 156.6 plus 273. 3.28 into 1000 divided by 8.314 into 256.6 plus 273. 3.28, yeah, 156, right? Melting point. So this is, I think I'm getting 0.91. Check your values. Yeah, so 0.91. So it is less than 2. So this will show non-faceted. So that means indium will be non-faceted. Okay. So here in the next slide, it is shown the list of element which shows the faceted growth and which does not show faceted growth. That means it shows the non-faceted one and the faceted one. So this green one shows for the non-faceted. That means some kind of dendrite kind of structure. So you can see all metallic elements like aluminum, zinc, cadmium, silver, copper, nickel, iron, vanadium, titanium, zirconium, scandium, iron, cobalt. All the metals which are there are going to show non-faceted growth. But you see metalloids like gallium, germanium, Sb, antimony, bismuth, okay, like silicon, germanium, carbon, boron. These are going to show this faceted growth. Okay, so hope guys you must have learned something new. Okay, so Thank you all for supporting us.